My head hurts, my stomach hurts, I'm groggy and thirsty. Why do I feel this way?
Hey! Do you really want to know? First, let's go over how alcohol is digested within the body. The active ingredient in alcoholic beverages is ethanol. In the liver, ethanol is converted to acetaldehyde by a dehydrogenase enzyme called NAD, which acts as a reducing agent. This step of the reaction happens quickly. Then, acetaldehyde is converted to acetate by the same enzyme. This is the rate-determining step, since the enzyme more readily binds to ethanol than acetaldehyde. This allows acetaldehyde to build up in the body when drinking in succession. Once acetate is produced, it can be converted to harmless carbon dioxide and water. The liver can only break down 8 grams or 10 milliliters of pure ethanol per hour, but that figure varies greatly from person to person. In addition to ethanol, if there is any methanol present in the alcoholic drink, it is converted to methanol and then formic acid inside the body. This process is completed using the same enzyme as mentioned before in the digestion of ethanol.
Acetaldehyde is a highly reactive compound and is a strong electrophilic chemical species that can react with a nucleophilic compound, such as an amino acid, to form a Schiff base, thus forming acetaldehyde protein adducts. An enzyme in the body acts as a base, abstracting a proton from the NH2 group on the amino acid. The electrons in the NH bond then attack the carbon on the carbonyl of the acetaldehyde, causing the double bond of the carbonyl to attack the proton on the water. On the intermediate, there is a proton hop onto the OH group, forming water, which is a good leaving group, causing a double bond to form between the nitrogen and carbon atoms. Water is a good leaving group.
And what do good leaving groups do?
They leave! This forms the end product, which is a Schiff base. In addition to acetaldehyde generation from ethanol in various tissues, acetaldehyde can also be formed from ethanol via bacterial oxidation in the mouth, stomach, and colon. Bacterial acetaldehyde production may be of special importance in upper gastrointestinal cancer and in the colon, where acetaldehyde may act as a carcinogen. As acetaldehyde accumulates, individuals increase in chance of developing upper gastrointestinal cancer. Acetaldehyde also binds to DNA, generating stable adducts with mutagenic properties. The DNA adduct is the segment of DNA bound to the carcinogenic acetaldehyde. This portion of DNA could potentially be the start of a cancerous cell. The occurrence of stable DNA adducts has been demonstrated in different organs of alcohol-fed animals and in leukocytes of alcoholics. Acetaldehyde also inhibits DNA repair by inhibiting an enzyme most relevant for the repair of adducts caused by alkylating agents. Acetaldehyde also binds to various proteins, changing their functional and structural properties and resulting in the generation of neoantigens with an antibody cascade reaction.
Now that we know the body handles alcohol, let's look at how that can lead to the dreaded hangover. First of all, scientists are not completely sure about the cause of a hangover. However, there are several possible reasons for its occurrence, and it's likely that a hangover is the net result of all these effects. The first and most obvious reason for feeling unwell after a night of drinking is dehydration. Alcohol is a diuretic, which means it increases urine production by decreasing the amount of antidiuretic hormones, especially vasopressin. Vasopressin is responsible for increasing the retention of water in the kidneys. Hence, alcohol reduces this, causing you to urinate more, leaving your body deficient of water. Dehydration can cause many of the symptoms that are associated with hangovers: dry mouth, sleepiness, dark urine, headaches, dizziness, lethargy, and others. Another possible cause for hangovers is the acetaldehyde that is produced on the initial oxidation of the ethanol. This substance is toxic to the body, and the acetaldehyde builds up when you consume a large quantity of alcohol in a small duration. Since this is the rate-determining step in the digestion of alcohol into non-toxic waste products, in larger quantities, acetaldehyde causes nausea, sweating, and increased heart rates. Some people, typically with East Asian descent, carry a gene mutation that causes the dehydrogenase enzyme to underperform in its breakdown of acetaldehyde. This causes a higher buildup of acetaldehyde, leading to more severe hangovers for those affected. Congeners are another source of symptoms. These are substances other than ethanol commonly found in alcoholic beverages. They are byproducts of the distillation and fermentation processes. The most common is methanol. Methanol is broken down to formaldehyde and formic acid, which are both very toxic in the body. The terrible migraines are theorized to be caused by cytokines, which is a protein that is synthesized in higher quantities when consuming alcohol by the immune system, leading to an imbalance in cytokine, which leads to migraines, fatigue, and memory loss.
So how do we prevent hangovers? To stop hangovers in the long run, some use medication called disulfiram, which is sometimes prescribed to treat alcoholism. It inhibits the body's ability to break down acetaldehyde, actually making your hangovers worse in order to discourage binge drinking. Another less torturous method of treating hangovers is drink more water after consuming alcoholic beverages. This will alleviate the dry mouth and other symptoms caused by dehydration. However, as we have outlined, there are many other causes for the set of symptoms that we call a hangover. Dehydration is only one of these causes, so it will not completely cure or prevent a hangover. Avoiding congeners can also reduce the symptoms. There are more congeners found in brandy, red wine, and whiskey than other types of alcohol, and there are less found in beer, vodka, and gin. Have you ever heard of drinking more alcohol in the morning to get rid of a hangover? It turns out that there is some validity to this idea. The digestive enzymes are more selective towards ethanol than towards methanol. Since the breakdown of methanol produces such toxic products, delaying its breakdown could postpone the hangover symptoms and allow the methanol to be broken down more gradually. This means that a Bloody Mary or a mimosa in the morning may not be such a bad idea. Drinking responsibly can eliminate a hangover altogether. Most people need to reach a blood alcohol level of 0.1% to experience the symptoms. However, there are many more factors to consider like genetics, overall health, age, and amount of sleep.
Another cause for hangover symptoms is sleep deprivation. Any deviation from the body's natural sleep pattern can cause sleep deprivation symptoms, which include fatigue, moodiness, irritability, depressed mood, difficulty learning, inability to concentrate, and forgetfulness. Alcohol suppresses melatonin, a hormone that facilitates sleep cycles. For this reason, drinking alcohol before going to bed can disrupt the circadian rhythm. Alcohol also elevates the body's level of adenosine, which causes sleepiness. This can throw off the sleep cycle by inducing sleep at an unnatural time. After going to sleep soon after drinking alcohol, the body metabolizes during approximately the first half of the night. This causes more time to be spent in deep sleep and less time in REM sleep. The REM cycle is actually important for much mental restoration involving memory and emotion, so skipping it is not such a great idea. In the second half of the night, the body is already metabolized, so its sedative effect dissipates, resulting in a rebound effect. The sleep becomes much lighter than it should be, leading to inability to sleep or micro-awakenings. Micro-awakenings are tricky because the sleeper may not even remember them, yet they still disrupt the flow and quality of sleep. Getting a good night's rest is nearly impossible after drinking late at night, causing hangover symptoms the next day.
Hangovers are one of the most common workplace productivity impairment. A study found that there is a significant relationship between alcohol consumption and next day absenteeism, with nearly double the chance to skip work after heavy drinking. Even if a person works while nursing a hangover, they feel significantly sicker, had a greater tendency to cause conflicts, had problems completing their tasks, and increased the likelihood of sleep during work hours. The effects of hangovers aren't just limited to adults, but are also seen as a plague with college students. Hangovers are seen to cause reduced productivity in students, commonly leading to poorer grades and academic performance. It has also been connected to impacting potentially dangerous daily activities like driving or operating machinery. More than 28% ended up missing classes, missing project deadlines, or work due to hangovers.
So, after much research, we have discovered only one surefire method of hangover prevention. Don't drink the Kool-Aid.